Voyager 1 is about to set another cosmic record. No other man-made object has ever ventured as far into space as this venerable probe. In just under a year, Voyager 1 will reach a new milestone, putting a whole light day between itself and Earth. In the future, it will take 24 hours for a signal from Earth to reach the old probe, and just as long again for us to receive a reply. But how is this even possible? How can we still be in contact with a probe from the 1970s that is now over 25 billion kilometers away from us? What does the magical light day limit mean for Voyager 1's future journey? And how much longer will the NASA veteran be able to provide us with unique data from interstellar space? Be sure to stay tuned until the end and find out with us. 25.26 billion kilometers. When Voyager 1 set off into the vast expanses of space on September 5, 1977, no one could have guessed that the probe would one day set such an impressive distance record. In fact, there is only one other space probe that has traveled as far from Earth, Voyager 2, which is now 21.15 billion kilometers away from its earthly home. While the identical twin probes have thus covered roughly the distance our grandparents used to have to walk to school, we must not forget that they were not originally intended to cross the boundary into remote interstellar space. Almost 50 years ago, the primary goal was to examine the outer planets of the solar system, which were still largely unexplored at the time. A rare constellation, in which all 4 large gas planets were aligned in an almost perfect line, allowed the duo to embark on their mission with minimal energy consumption using so-called swing-bys. And while Voyager 2 subsequently visited Jupiter, Saturn, Uranus, and Neptune, delivering unique images and data, it was time for its sister to bid farewell to our planetary system after passing Saturn. More precisely, NASA officials sent Voyager 1 toward interstellar space in November 1980. And since that's not exactly around the corner, it took her over 30 years to reach her destination. However, this is not because the aging probe creeps through space like a snail. Because at the end of the day, Voyager 1 races through space at a speed of around 61,000 kilometers per hour and covers around 540 million kilometers annually. The journey of humanity's most remote outpost reminds us of how vast the distances are, even within our home world. But what does it actually mean when we say that the Voyager probes have passed the edge of the solar system? In other words, where does our home system end, and where does interstellar space begin? The advance into uncharted worlds. Well, that's a matter of definition. And if we want to be really precise, the duo is still in the solar system. The bottom line is that the gravitational pull of our host star extends far beyond the zone in which the Voyagers are currently located. It extends to the remote Oort cloud. This is a reservoir of comets that begins about 2,000 astronomical units, or around 1.6 light-years from the Sun. However, it will take an estimated 300 years for Voyager 1 to reach the edge of this region, and another 30,000 years to cross the entire cloud. What the probes have already crossed, however, is the heliopause. To understand what this means, we need to briefly consider the overall structure of our home world. The Sun emits a constant stream of charged particles, known as solar wind, which forms a gigantic bubble that shields us from dangerous cosmic radiation from interstellar space. This bubble is called the heliosphere, and its edge is called the heliopause, beyond which begins interstellar space, or in other words, space far away from stars. This is where the influence of the solar wind ends, and the battle between 2 powerful cosmic forces begins. Arriving there in 2012 and 2018, Voyager 1 and 2 showed us that this border region is not a calm, clearly defined zone, but a surprisingly dynamic transition zone characterized by high-energy cosmic radiation, fluctuating magnetic fields, and plasma waves that extend far beyond the heliopause. Never before have we been able to catch a direct glimpse of these extreme spectacles. Thanks to the revolutionary data, we are learning exactly how the heliosphere interacts with the local interstellar medium and gaining important insights into the nature of a previously unfathomable cosmic world. And although the Voyager mission has already achieved a whole series of significant milestones, the aging probes continue their journey undeterred. And Voyager 1 is now on the verge of setting another amazing record in space. Voyager 1 breaks through the daylight boundary. It has now been over 17,600 days since Voyager 1 left Earth. And as mentioned briefly earlier, the probe has traveled a staggering 25.26 billion kilometers in all that time, putting it around 167 times further from the Sun than Earth. Just to remind you, the average distance between the Sun and Earth is known as an astronomical unit and is around 150 million kilometers. The highest speed ever achieved by a manned spacecraft was set in 1969 by Apollo 10. At that time, the spacecraft reached a speed of just under 40,000 kilometers per hour. But even at this top speed, it would take 3,730 hours, or 155 days, for a crew of astronauts to cover even a single astronomical unit. Light, on the other hand, travels a little faster. To be precise, It reaches a speed of 300,000 kilometers per second in a vacuum, which is why it only takes 8 minutes and 20 seconds for the light emitted by the sun to reach Earth. Within a day, light covers a distance of 25.9 billion kilometers, exactly the distance that will separate Voyager 1 from our blue home planet in just under a year. It will then take 24 hours for signals from Earth to reach the probe, and consequently just as long again for us to receive a response. However, those responsible for communication do not have to make any dramatic changes. Even now, it takes 23 hours, 29 minutes, and 27 seconds for a message to travel the immense distance. The fact that we can stay in contact with the Voyager probes at all is thanks to the Deep Space Network. This is a global network of monster antennas that can receive tiny radio signals from billions of kilometers away and send commands back to the probes. Okay, but when exactly will Voyager 1 break through the historic daylight mark? Well, to determine this precisely, experts have turned to Eyes on the Solar System, a software developed by NASA that can simulate and visualize the solar system, space probes, and their missions in real time. In this way, Voyager's light day date could be set precisely to November 13, 2026. From a purely scientific point of view, this distance record is unlikely to yield any groundbreaking new insights, yet it has extraordinary symbolic value. Although the Voyager probes repeatedly make headlines with technical difficulties and have already caused some headaches for those responsible, they are a prime example of endurance and robustness. From a purely technical standpoint, the duo is of course outdated and hopelessly inferior even to the smartphones in our pockets. But nevertheless, the probes are opening up insights into worlds that were previously the great unknown. But since even in the vastness of the universe, everything comes to an end at some point, the question naturally arises as to how long this will still be possible, and how the longest-running success story in space travel will continue in the future. The end of the Voyager mission, and the beginning of a new journey. Scientists generally assume that the Voyager probes will be able to deliver data from interstellar space until well into the 2030s. However, the end of the mission is not due to the ever-increasing distance, but to the fact that the duo is slowly but surely running out of juice. Specifically, the probes are powered by radioisotope thermoelectric generators, and since the performance of these plutonium batteries decreases over time, NASA is already pursuing a strict power-saving plan designed to delay the end of the mission for as long as possible. To this end, more and more instruments on board that are not essential for continued operation are gradually being shut down. And yet the day will come when the probes will no longer have enough energy to keep their instruments and communication systems active. However, and this is the exciting part, the end of the scientific mission does not mean the end of the Voyager journey. The probes can continue to fly without energy, simply because they move through space with virtually no friction. Against this backdrop, experts estimate that the Voyagers will continue to bear witness to our existence for millions or even billions of years to come. But what will they see during that time? Well, as mentioned briefly earlier, Voyager 1 will reach the inner edge of the Oort cloud in a few centuries and will take 30,000 years to fly through the remote collection of icy chunks. Incidentally, it's extremely unlikely that the probe will fall victim to a brutal comet bombardment, because in reality, space is not the densely packed, deadly obstacle course we know from science fiction films. But then there will be nothing for a long time. Voyager 1 will drift through space alone and far away from astronomical sources of heat and light for about 40,000 years. Then, however, it will pass the star Gliese 445 at a distance of 1.7 light-years and come closer to it than the Sun. In fact, Proxima Centauri, 4.8 light-years away, is the star closest to the Sun. But since even the brightest celestial bodies do not remain stationary in space but are constantly in motion, Gliese 445 will move significantly closer to the Sun in the coming millennia, enabling it to rendezvous with Voyager 1. According to experts, however, this will only mark the beginning of many more stellar encounters. Statistically speaking, Voyager 1 will come so close to a star every 50,000 years or so that it will pass within 1 parsec, or about 3.26 light-years. The probe will experience its next close encounter with a star in about 303,000 years, when it will approach the main sequence star TYC 3135-52-1 to within 0.965 light-years. However, based on the data, it's unlikely that the probe will be captured by a star in the foreseeable astronomical future. The time it takes for a space probe to collide with a star is in the order of 10 to the power of 20 years. That's about 7 billion times the age of the universe to date. Unless something unforeseen happens, the probes still have a very long future ahead of them, even if their scientific mission is rapidly coming to an end. And if you click below our video now, you'll never miss another post from us. Just press the thumbs up button and subscribe to stay up to date from now on. See you soon.